Hello, everyone. I'm happy to start a new mini series where we are going to discuss about deploying CPU and GPU based inference in serverless architecture. Before we get into the further details, first let's try to understand the need of serverless architecture. In the previous mini series, we discussed how you can use batch inference for non-real time workloads. Serverless architecture is one of the best way to handle non-real time workloads. Let's try to understand this with a simple analogy. Server based architecture is more like owning a car. It's a comfort, but at the same time, you need to maintain it. You need to fill the gas, you need to pay the insurance premium. Doesn't matter whether you are using it or not. Imagine at 3 a.m. when you are sleeping in your bed, you're still maintaining your car. You are paying the price for it. However, serverless architecture is more like pay only for the usage. Like renting a car. Imagine you want to move from point A to point B, you book a Uber and you transit from point A to point B, but you pay only for the time of transit, which is from A to B. Relatively, it's way more cheaper than owning a car. But based on these two scenarios, it's very clear that server-based architecture are more apt for the use cases which needs real-time response. Owning a car is more like a comfort. As soon as you want to start somewhere, you can take your car keys and get started. But in case of serverless architecture, it's not the way because you need to book the Uber, you have to wait until the car arrives. So this process of waiting between your request and getting started with the service is called cold start. So if you are processing non-real-time workloads, serverless architecture are going to be the best option for you. And in this series, we are going to discuss how we can deploy a CPU and GPU based inference using runpod serverless architecture. Let's try to understand the use case. So we are going to build this series with a bottom-up approach. To start with, we need a CPU-based model. For this, I have taken Kokoro TTS inference model. This model is available in Hugging Face. It just contains 82 million parameters. It's a very tiny model which can run in your CPU machine. The model takes text as an input and provides audio as an output. Now, as the first step, we will be developing a very simple standalone inference which can run in your computer. But in order to deploy this model at scale, you need an API layer on top of it. For that, we are going to use the FastAPI layer. So the FastAPI layer is going to consume your text and pass on the text to the Kokoro model and Kokoro generates the audio and it returns back to the first API layer, and the API layer is going to return back the response. Now, in order to deploy this application at scale, we are going to use the runpod environment. The runpod provides a very, very simple way to deploy serverless based models. For that, we are going to containerize this entire process and create a Docker image. Once we have the Docker image, we can easily spin multiple instances of the runpod worker and create one particular endpoint. So once we have this endpoint in place, we can develop a dummy UI. So user types in some text from the UI, and then when hits submit, the text goes to the runpod server as endpoint, and the endpoint will check which worker is active and send the text to one of the worker, and the worker consumes this particular text and it goes to the API layer. API layer sends it to the model layer. Model consumes the text, converts it into the audio, and it goes all the way through UI where you get the response. So we are going to create this end-to-end architecture step by step and test this workload with CPU and GPU based endpoints. Let's get started.